In the world of aerodynamics, understanding how air moves around objects is crucial. One key concept is the Kutta condition. This principle, named after German mathematician Martin Kutta, helps us understand how air behaves near the sharp trailing edge of a wing, known as an airfoil. The Kutta condition simply states that air prefers to flow smoothly off the trailing edge of an airfoil. Instead of flowing around the sharp corner, which would create a very high velocity and low pressure zone, the air chooses a path that results in a smooth, continuous flow. This may seem counterintuitive, but it's how nature works. The Kutta condition is a fundamental principle that helps explain why airplanes can fly. By understanding it, engineers can design more efficient and stable aircraft. Martin Kutta was a brilliant mathematician and aerodynamicist who made significant contributions to our understanding of flight. In the early 20th century, he observed that air doesn't behave as predicted by basic fluid dynamics when it flows around a sharp corner, like the trailing edge of a wing. His observations led him to formulate the Kutta condition, which revolutionized the field of aerodynamics. The Kutta condition helped to reconcile theoretical predictions with experimental observations, leading to a more accurate understanding of lift generation. Kutta's work laid the foundation for modern airfoil design and our ability to predict the aerodynamic characteristics of wings. His legacy continues to inspire engineers and scientists today. Airfoils, the cross-sectional shape of wings, are designed to generate lift. The Kutta condition plays a crucial role in this process. When air flows over an airfoil, it is forced to travel faster over the curved upper surface than the flatter lower surface. This difference in speed creates a pressure difference, with lower pressure on top and higher pressure below. The Kutta condition ensures that the flow separates smoothly at the trailing edge, maximizing the lift generated. Without the Kutta condition, the flow would separate prematurely, leading to a loss of lift and increased drag. This principle is essential for the efficient operation of aircraft. The Kutta condition is not just a theoretical concept, it has practical applications in calculating lift. The Kutta-Joukowsky theorem, named after Martin Kutta and Russian physicist Nikolai Joukowsky, provides a mathematical relationship between the circulation of flow around an airfoil and the lift it generates. The theorem states that the lift per unit span of an airfoil is directly proportional to the density of the fluid, the free stream velocity, and the circulation around the airfoil. The Kutta condition is essential in determining the circulation, linking the smooth flow separation at the trailing edge to the lift generation. This theorem is a fundamental tool for aerodynamicists in designing and analyzing aircraft wings.